Hi students, welcome back. So in the previous video I explained the sorting technique. So that is in the database management system. So the databases will use only the external merge sort algorithms to sort the values in the database. Okay, so in the previous video I explained what is an internal sort and what is an external sort and the algorithm of this external merge sort algorithm. Merge sort. So now let us see the example. So based on that algorithm, okay, so whatever I said in the previous video, the algorithm steps, by seeing those algorithm steps, okay, we will calculate, we will merge the record. Okay, let us take one example. The elements in the database 8, 18, 11, 16, 13, 12, 17, 21, 15, 19, 20 and 14. Okay, so let us take, so these are the file which contains the unsorted data. So this is the unsorted data. So let us take M is 3. Okay, so M here is the 3. So now you have to take only the 3 values at a time. 3. Okay, so if it is 2, no problem, it is leave it. Okay, so first 18, 11, 16. Okay, so first you take these two series. Okay, so here you just arrange these two in sorted order. So how you will arrange this in sorted order? So this is 11, 18, sorry 11, 16, 18 and arrange these two in sorted order. 12, 13, 17. Okay, and this is in sorted order, means take the individual file and sort it. So here the 15, 19, 21 and this is 14 and 20. So the particular, the single files will be sorted. Okay, so now this is after first run. After first run the output is like this. So we have taken the elements, so we'll done first run process. So after first run, this is the process. Okay, now you have to be do the external merge sort algorithm. So these 3 and these 2. So we have to be focused on these 2 and you have to focus on these 2. You have to done the merge sort in these 2 elements and these 2 elements. Okay, so the starting elements in here is 11 and 12. Okay, so in this 11 and 12, which one is the you take the buffer block. So the buffer block size is only 3. So up to 3 values it can store. Okay, so here 11 and 12. So in 11 and 12, which one is the least number? 11. Okay, so then strike off the 11 and place that value in buffer block. So the output value should always placed on the buffer block. So we discussed in the algorithm. Okay, the output buffer block will be placed and after that it stored in the disk. Okay, so 11 strike. After that 11 you are having the value 16. So now check 16 and 12. So in 16 and 12, which one is the least? 12 is the least. So strike off the 12 and place 12 in buffer. So after 12 you are having 13. So in this do check which one is the least one. 13 is the least one. So check it and place it in the buffer. After 13 you are having 17. So you have to check the after striking the value. Okay, what is the next value that you have to be right here. Here the buffer is full. So whenever the buffer is full, okay, you place that output in the disk. So now write the output value 11, 12, 13 on the disk and make the buffer block empty. Okay, now I make the buffer block empty. So now here we have to check 16, 17. Which one is the least one? 16. So strike off 16. So after 16 you are having 18. Write 16 here. So in 18 and 17 you check which one is the least? 17. Strike off 17. Write 17 here. 17 after Okay, so 17 after you are having here nothing is there, so this block is sorted. Okay, so after 17 you are having only 18, so this block is full. In the same way, here you have to check these two series. So first you place you check 15 and 14. So which one is the least one? 14 is the least value, so strike it off. Okay, place the 14 here. This is the buffer block. So after 14 you are having 20. So check 20 and 15. Which one is the least? 15. So strike it off and place 15 here. Okay, after 15 you are having 19. Now check 19 and 20. Okay, so after this operation you just place it 16, 17, 18. Write it on the disk. Okay, so after 19, which one is the, means 19 and 20, which one is the least one? 19. So strike off 19 and place 19 here. Okay, so after 19 you are having 21. So this is the full. Okay, so take another buffer block. Okay, so in this two you have to check 20, 21. 20, 21. Okay, so in the same procedure you have to be followed. Okay, this is sorted, so you have to done the merge sort in these two, like that. Okay, so finally you will get the output as 11, 12, 13, 16, 17, 18, 19, sorry, I'm sorry. So after finally after doing the merge sort like this, external merge sort, okay, again you will sort these two and these two, two files like that. The final output that was stored in the disk is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so this is the way how you have to be calculate the external merge sort. Okay, just take the two because the M is 3, the buffer block should only carry up to 3 values. After that you have to place that in the disk, and again you take another buffer block that should be empty and place the values there. Okay, so you have to be first partition the values and make the merge sort between those files. Okay, now let us see the cost of external merge sort algorithm. So how we calculate the external merge sort algorithm. So let us see that cost of external merge sort algorithm. Okay, so let us see what is how to calculate the cost of external merge sort. So actually the formula for external merge sort is, first is number of passes is equal to 1 plus CL of log b minus 1 CL of n by b. Okay, and the cost is equal to 2n star number of passes. Okay, so if you find the number of passes, then you will get the cost of the external merge sort. Okay, so here this n is nothing but the pages, how many, the length of the numbers, the pages that you are using. Okay, and the b is nothing but the buffer. Okay, how many, what is the size of your buffer, that indicates the b. Okay, let us take the example. Let us see how the cost will be calculated for this external merge. Suppose with 5 buffer pages, we have taken the 5 buffer pages to sort 108 page files. Okay, so here total you are having 108 page files are there. Okay, then is 108 page files are there. So there are 5 buffer pages. So in each buffer they will store only the 5 values will be stored. So total it has 108 pages are there. Okay, so in each buffer you have stored only the 5 pages. Okay, like that. So now see the first pass 0. So what's the operation here? Seal of 108 pages by 5. Okay, this is equal to, here 22 sorted. How you will get the 22? 108 by 5 means 2, it's 8, 1 point something. Okay, 1.2 like that. Okay, so this is a seal off means you have to make it as a rounded. So 22 you will get. Okay, so 21.6 is it there. So rounding of 21.6 you will get 22. So seal of 108 by 5 is equal to, you get 22 sorted runs. Okay, runs you call these. So these you call the runs. So this is the first run. After that again I had done the second run. After that again I had done the third run, like that. So those are the runs. Okay. So in the first pass 0, it should be 22 sorted runs of 5 pages each. So you could, here they are saying that there are 22 sorted runs are there. Okay, means 22 slots are there. Instead of 108, these will be converted into 22 sorted runs. Each sorted is having 5 runs of 5 pages each having the 5 pages. So after completing the 5 pages, the still remaining will be here, last runs is only 3 pages. Okay, so in the 22 sorted runs, so last run, whatever the run that is present in the last, because this is 21.6, right? So 21.6 means still 3 more you have to be add here. Means 21 point, if you want to get 22, still 3 more pages have to be added here. Okay, that's why last run is only 3 pages. Okay, so now coming to next pass 1. So here in the pass 1, what you will do actually, according to the algorithm, now do 4-way merge. Means 4-way means you are having the 5 buffer page. So 5 minus 1 you get only the 4. Okay, so 4-way merge, that is b minus 1. So according to the algorithm you have to do b minus 1 or m minus 1 like that. Okay, so now in the pass 1. So in the pass 1, so what is the seal? So here already it is sorted to 22. Instead of 108, it sorted to 22. So now 22 by 5 minus 1, 4. Okay, seal of, what is the value? 6. 6 sorted runs of 20 pages each. And the last run is only 8 pages. Okay, so last run consisting of only 8 pages will be there. Okay, so now coming to the pass 2, means next level, next sorting again. So what is here? So here already the sorted is a 6. So 6 by 4 minus 1, 3. The seal is 2. Okay, so 2 sorted runs, 80 pages and 28 pages will be there. Now coming to the last pass 3. Why I am saying this is the last pass? Because 2 by 2 you will get only 1. That is, all the file is completely sorted. The file is completely sorted. Okay, so sorted file with 108 pages. So this is how you are calculating, means you are finding out, we are sorting the page which consisting of a buffer page, 5 buffer page to sort 108 page files. So this is a formula for calculating the cost, and this is the way you are applying the formula, and you are sorting with the help of algorithm, you are sorting the pages. Here 108 pages will be sorted according to these steps. Thank you.